We also need to look at problem solving with Venn diagrams with 3 sets, because otherwise you'll find it hard to solve task 3 on page 314. And there are no examples with 3 sets in the book, I think. So we'll set up an example here. So we imagine a survey where they ask people, do you like orange juice, apple juice, or grape juice? And people were free to answer none of the above, or they could like a combination of 2 or more. And here are the replies. So out of the 145 who were surveyed, 15 liked none of them, 55 liked grape, 80 liked apple, 75 liked orange, 35 liked orange and apple, 20 liked orange and grape, and 30 liked apple and grape. The question we want to answer is, how many liked all 3 of them? So how many of the 145 liked both grape and apple and orange? And we're going to call that that number that we want to find, we're going to call that x. And the way to solve this, to answer this, is to make a Venn diagram and fill out the information that we have. So we'll start with that. Okay, so this is our Venn diagram, and we have the 3 circles. Here is apple juice, here's orange juice, and here's grape juice. And we have the size of the universal set, the number of elements in U is 145. And right here in the center, we can put our X, because that area in the center happens to be the intersection between all 3 circles. So that area, this area here, is part of all 3 circles. And we call that the intersection of A and O and G. Now, the way we write that is, let's see, we write that as the intersection between A and O and G. And this symbol here, we translate that with intersection, because these are intersecting circles. So this would be the intersection between all 3 circles. We have other intersections as well. We have this one here, which is the intersection between orange juice and grape juice. This is the intersection between apple juice and orange juice. This is the intersection between apple juice and grape juice. And we can now proceed with numbers for these intersections, which are these petals near the center. So we have the number of elements in the intersection A and O. So these are the people who liked apple juice and orange juice. So we know that they are 35. And that would be, let's see, apple juice, orange juice, so that's this area here. Yeah. And we also have the number of elements in orange juice and grape juice. So this is the intersection orange juice and grape juice, 20 people. We also have the number of elements in grape juice and apple juice. And that was 30 people. And now we have to solve this one petal at a time, because if I write 20 here, that's not correct, because it's the intersection between orange and grape that is 20. So that's this whole area here. So, but if I subtract x, like we did in the previous example, then that would be correct for that area. Similarly, this intersection here, if I write 35, that's not correct because 35 includes the area with the x, so this is 35 minus x. So 35 minus x in this area here. And if we add the x, then we get all 35. And down here we have 30 minus x. So now we have filled in something for all the petals. Okay, so what else do we know? Well, we know that the number of people who liked apple juice, that was 80. So the number of elements in the set A is 80, which is this whole circle here. So that would mean that if I write, okay, we know that 80, that's the whole circle. And if I subtract 35 minus x, and if I subtract x, and if I subtract 30 minus x, then what am I left with? Okay, it's going to look like something like this. 80 minus 35 minus 30 plus x minus x plus x equals, that's going to be 15 plus x. So what did we do here? Well, we know that the whole circle A contains 80, and now I've just subtracted these petals, 80 minus 35 minus x, and remember the brackets here, the parentheses, because that's important. So we're subtracting this petal here, and we're subtracting the intersection in the middle, and we're subtracting this petal here. So that should leave us with only this area. That's what we're left with. And once we clean these up, 80 minus 35 minus 30, so we just move around things here, just like we're allowed to do. We're going to be left with a simple expression, 15 plus x. So we can write that here. And let's do the same for orange juice. We know that the number of people who liked orange juice, that was 75. So the number of elements in the set orange juice is 75.